Next up, we have Aleksandra, who will be teaching us all about well, uh, code quality, developing web application testing pipelines. Aleksandra is a QA lead at code quality platform Codana, part of JetBrains, and one of her hobbies is dancing. She loves to dance.
Yes.
So it's a short intro for this one. So let's get on with the session as there's a lot to fit in. Over to you.
Yeah, thank you so much. Yeah, it's very lovely to see you here. Yeah, so let's start. Hi, everyone. My name is Aleksandra, with a difficult to pronounce surname. So today we will go through a step-by-step guide for building a web application testing workflow from scratch that we created during the Codana cloud development. So before we get started, I think it would be helpful to offer some context about why we found ourselves building our own web application testing workflow. So um, yeah, let me introduce myself. I have an unusual combination of two different roles. I work as quality assurance lead at the code quality platform Codana, and today we will discuss the testing approach in this team. And also, I'm a product manager in the JetBrains IDE. So, JetBrains Aqua, which is a powerful IDE for test automation, and we will announce it soon. So please stay in touch and subscribe our blog. Don't miss announcement. Yeah. And also, I share my knowledge with ours by mentoring QA colleagues, such as in Women in Tech programs, supporting women in testing as a Women Tech Makers ambassador, and also speaking at professional conferences. So that's all about me. Let's start our story. Our story starts about 6 months ago when we started developing Codana Cloud, a solution for storing reports from our linters for static code analysis. So Codana brings all the smarts of JetBrains ideas to CI pipelines. That said, you and your team can automate routine tasks like code review, debugging without actually leaving the JetBrains ecosystem. And that is particularly important. Codana uses the same code inspections and profiles as your JetBrains IDs, so you can configure checks, rely on them locally, and ensure rules for whole team with server-side quality gates. So with Codana Cloud, we can gain a high-level view of projects with interactive dashboards and drill down into particular issues to learn more. So it was a little bit about our product. And yeah, Codana Cloud is a classic web application with a backend and front end, and we started development with several backend and front end developers, and just only one quality assurance specialist. Resources were limited, and tasks, as usual, were plentiful. So, nevertheless, we wanted to build everything from scratch because doing so would allow us to provide the best product possible. Yeah, and um, we when we on the Codana team were dreaming about building a web application testing pipeline. We thought figuring out where to start would be really trivial. So, well, it turns out the task actually presents us with enormous number of questions without clear answers. For example, which product stack should we use, and would we use Cypress or Selenium to write UI tests? And what about writing API or unit tests? Should we set any requirements for test coverage? How often would we run tests? And how many more questions do we have? So posing all of these questions opened a lot of door for us, but we didn't know which one to enter, and we didn't know where to start. And at the same time, we also understood that this was only one chance to really get it right. So the cost of many solutions would increase once product development started. So one of the challenges we noticed was a general lack of comprehensive information. We found that building a pipeline from scratch requires experience writing unit tests from scratch, or at least guides about how this is done. But since the project is rather difficult, we found there weren't many resources of the sort we needed available. That's why we decided to put this guide together, and we wanted to provide the materials that would help us. So imagine that you are building from scratch and you want to build test automation process. Since you don't have any legacy code to deal with, there is nothing stopping you from creating perfect testing pipeline. It's a dream of each QA automation specialist. Um, what would you do in this case? Where we would start? What would be the most important factors to consider? You can comment in the chat if you have any ideas. I hope you have. Yeah. So in this guide, I'm going to lay out the approach we took. I've broken it down into 7 steps. So steps is ensuring testability, putting unit tests on Rails, test automation strategy, implementing integration tests, implementing system tests, of course, testing the API and the UI integration, and finally implementing the testing pipeline. I mean CI/CD pipeline, yeah. So let's start from the first step. So our one of the highest priority characteristic of a system is testability. As you know, any modern development pipeline includes test results and our metrics for each commit. Such a pipeline must meet a few basic requirements. So the first requirement is the ability to deploy the product locally. And not just to deploy it, but to do it so quickly and easily. And quickly, of course, it's a loose concept, but in our case, we're talking about a couple of minutes, and at worst, no more than 20 minutes. So the second requirement is identical functionality between the local and production environments. And the local instance and production one may differ with respect to allocated resources, for example, but the situation in which a feature works differently on the local instance than on the production calls any test results into question, of course. And the last point is ease of testing for both the entire application and its individual parts. This is actually a matter of using modern design patterns and the modern technology stack. So it's critical to invest enough resources in system testability when you first start developing the application. Otherwise, the cost of achieving this characteristic will grow exponentially in relation to the lifetime of an application, which means the later you can start testing, the more it will cost you going forward. So at Kadana Cloud, we have invested time in testability and implemented the containerization of database and all microservices. The database and all backend microservices are assembled into Docker images with specific run command. Here on the slide, it's make start local, make stop local. And the whole process of launching the application takes no more than 20 seconds. And the local and production environments are identical. From the point of view of application testability, we implement the front end and backend using the popular technology stack. Of course, it's Kotlin and Ktor for backend, and JavaScript and React for the front end. So the testing of individual components take place in a traditional manner, nothing special here. Yeah, and we proceed with the next step. As soon as we have taken care of launching the application and start developing our features, we need to be ready to immediately cover them with unit tests. And as we all know from the testing pyramid, unit tests are the quickest and closest to the code. So in additional, unit tests typically fall under the developer's responsibility. So I think we need to control their implementation. And the following substeps are crucial for putting unit tests on Rails. So first of all, we need to create an infrastructure for quickly writing unit testing. The most basic option is to create a task for developers and ask them to implement all of the entities for the first features. But even the presence of ready-made infrastructures does not guarantee that unit tests will be written correctly. One way to reduce the likelihood that tests will be written poorly is to provide instruction on the basics of testing. For example, we can cover below topics. First of all, how to write basic test case. For example, a common problem with unit tests, a common problem with unit tests is ignoring negative scenarios. So the next step we can do is how to use basic test design techniques. For example, boundary value analysis or equivalence partitioning testing. And also, I think it's important prepare some instruction how to create the minimal set of required test cases. And unfortunately, even if you do both of these things, you still have no guarantees that the unit test will actually be written. So your next course of action is to provide control by setting a required level of test coverage for unit tests. And I think the main mistake here is to wait until you reach a high degree of test coverage, for example, 80%, and only then set it as a quality gate. So if you don't know what a quality gate is, it's a gate in the CI/CD pipeline that requires a specific metric to be met, and only after a job will be allowed to continue. So actually, there is no need to wait for ideal coverage. Our main task is rather to prevent the level of coverage from dropping. And this is why on the Kadana team, we use this coverage as a quality gate from the very beginning, and then gradually raise the requirement as part of our plan to increase coverage to our target value. And also, I would like to emphasize that it's important not to focus on absolute numbers, but rather the creation of the high quality of product. And in my experience, unit test coverage is optimal in the 70-80% region. So let's see how we address unit test coverage in Kadana. We set up the infrastructure for tests and implemented test-specific code, as I said, using KTOR and SQL transactions. So nothing special. You can see like basic test cases here. And next, we gave a lecture on the basic test theory to developers, and also wrote documentation with a step-by-step description of what is required from API testing. You can see that we require test coverage for every status code, a mandatory negative script, and validation checks for all HTTP request parameters. As for test coverage, from the beginning, we set a high level of 60%, and over time, it has grown to 65%. Unit tests and coverage were immediately integrated into the CI/CD pipeline for each commit as a quality gate, of course. As you can see, the CI/CD pipeline currently takes quite a long time, 13 minutes. the application takes a long time to start because of the agent infrastructure, and one of our future goals to make the pipeline execution several times faster. So let's continue with next step. Finally, we have reached our direct area of responsibility. It's automated integration and system level tests. So here it's important to choose a test automation strategy. And as today we are talking about web applications, which means we have a backend and front end, and they are written in different programming languages. So this leaves us with three options. And the first option is to write everything in backend language. I mean, all automated tests for backend and front end. And the second is to use front end language. And last option is a combination. So to use both languages separately. Let's see deeply into the first option. So using the backend programming language, and what we can reuse its data classes from the product code, and also we can reuse here HTTP backend methods in front-end tests. So the downside of this option is that unit testing flow is separated from the front-end development, which means it will be difficult for a front-end team to fix issue in the automated test, since this test will be written in backend language. So front-ends are not familiar with this language, of course. So second option is to write all tests in front-end programming language. The advantages here are that we have a common flow between UI tests and front-end development. And we can reuse HTTP backend methods in front-end test. But the downside is that the backend development is separated from the API testing flow because we are using different programming languages and we aren't able to reuse data classes. So as a result, we need to duplicate them. And a typical example of setup like this, and it's when you decide to write front-end and back-end tests in Cypress, for example, or Playwright, okay. Yeah, so the third and the final option is to write automated tests in two different languages. In this case, we can reuse our classes from the backend, but we lose the ability to reuse HTTP backend methods from backend tests, for example, for data setup in front-end test. And as a result, we need to duplicate all these entities. So of these three possible options, the Kadana team choose the first one. And right, because of two reasons, I think. Yes, first of all, first reason is that we wanted to reuse entities wherever is possible, so it's first variant. And also the second reason is that since we follow the testing pyramid, there will be many more API tests than system UI tests. So it's given us an incentive to focus on backend optimization. Yeah, so it was about different programming languages for test automation. And once we have chosen our programming language, we next need to decide where to write the tests, with a product code or in a separate repository. So let's look at the difference between the approaches, starting with a split flow, which is when the product code and test are in different repositories. And in this case, the developers write a new feature and create a new merge request. When most likely the merge request triggers a test run in our test repository to check the new changes. And in the event of test failure, regardless of the reason, we will need to wait for a fix, which will require an hour full review process in the test repository. So we actually waste time and create a bus factor due to the product code and test code changing between different flows and repositories. So the next possible variant is when we combine the development and testing flows using a common repository for automated tests and product code. The developers write feature the same, and in the event of test failure, fix them directly in the same repository. I think it's really convenient, and this setup also allows us to add or extend the test of a feature directly in the same merge request. So additionally, we have created interchangeability here. So if a test automation engineer or developers goes on vacation, a developer can always fix the test, and test automation engineer can always fix the code. So given these advantages, it is perhaps unsurprising that we choose this option with mono repository. Yeah, and we proceed with step number 4. After choosing a test automation strategy, actually it's time to focus on implementing integration tests. This stage can be broken down into 3 steps. So the first steps is choosing a testing framework. And I think everything is quite simple here. We need to choose the most popular tools for desired programming language and just implement infrastructure. So the second step is to build the process for expanding integration tests and specifying the circumstances in which we want to expand and use different sets of scenarios. So the third step is implementing test control and implementing the automatic maintenance of a good degree of coverage and test stability. Here, how we done this stage in Kadana? We start by looking at backend testing, okay? So because the Kadana backend is written in Kotlin, and it's and the most popular framework for API testing here is Rest Assured, of course. It's lightweight, it's quite flexible. And as we discussed earlier, we can reuse code from product, for example, code models and data classes. So the expansion strategy was to add integration tests to the merge request where features were developed. And the united flow of develop and testing as a result. So moreover, such convenient infrastructure allows us to prepare manual test cases, but to write them in the code as automated tests without additional preparation or manual test cases. So also to analyze our test API coverage, we use the Swagger API coverage. This is automatically calculates coverage according to the open API documentation. And I think it's a cool tool that I can recommend trying out. So also, we have set a low degree of coverage because it's not always practical to cover all of the get parameters in HTTP requests, but we have plans, of course, to expand the coverage further. And if we are talking about UI testing, I think the stage of implementing integration tests are very similar to the stage of building unit tests, but there is one significant risk, I could say. A common mistake is to forget about UI tests at the integration and unit testing level. And we make use of both component and storybook UI testing at the integration level. In our case, the front-end team is responsible for this test because they are implemented in JavaScript and located with the front-end repository. Okay, and we're really close to the next step, and we climbed the testing pyramid all the way up to system tests. As you know, the purpose of system tests is to simulate user behavior and verify that critical scenarios work. So our steps remain the same. Choose a stack and implement different infrastructure classes, decide what to cover with automated tests, and the most important, determine detect how to track the degree of coverage. And the Cardano team chose Selenit, of course, because it's the most convenient UI framework for the GVM stack. It's high-level Selenium wrapper with built-in smart weightings and convenient asserts. And also, we can reuse data classes and API request classes to set up data before the test, or, for example, to clean up data after test. And for example, here on the slide, you can see we generate data using methods that we already implement in backend tests. This way, we don't need to duplicate code, and we will immediately see an error if something in backend changes how the data is generated. Okay, so as for last stage, here the minimum set of automated test cases contains the main user features going into release. So also it's possible to cover them according to the main product requirements, for example. So there are a lot of possible ways how to do it. And also, coverage estimation is a bit more complicated tasks for UI testing. There aren't any effective tools for analyzing the test coverage of UI tests. So we use the user case map and manually mark scenarios as covered with an automated test. Okay, so we go into next step. So the next step, we need to think about testing API in conjunction with UI. So, for example, which version of API should we use, and how can we make sure that API and UI work properly together? And our solution is the green main branch approach, which requires us to make sure that all features merged to the main branch always have green tests. And there are several ways to support such approach. For example, you can keep your main branch always ready for release state. If you want to release, for example, very frequently, several times per week. But in this case, you have to finish all features before merging, or should be aware of hidden features from the main application. Yeah, it's a really uncomfortable place here. Yeah, and another way is to make release branches that will be considered green main branches. This method is more suitable for long-term release cycles. And in this case, we can keep unfinished features in the development branch and keep all release features in the release branch. You may be wondering why we are thinking about the release process as we build product quality, but I think the truth is that we cannot build automate control without considering the release approach. Otherwise, the release process will be a big place for bottlenecks and unexpected bugs, of course. So we in the Kadana team choose the release branch, and we just launched our product, so still have a lot of upcoming features. But later, when our release process is fully prepared, we will be able to migrate the main branch to ready to release state. And regarding API and UI integration, we automatically test the latest green version on the backend release branch with the latest version of the front-end release branch. And this ensures full compatibility between backend and front-end testing. So because the API tests in the main branch are always green, and the UI tests use the latest version of the backend main branch, we are able to ensure API and UI compatibility. Yeah. So it was about release process a little bit. Final step is implementation of a modern testing pipeline using CI/CD, of course, and quality gates, of course. And for this stage, it is crucial to include critical, fast, and stable checks. And the popular strategy for CI/CD pipeline is fail first. This means the first check should evaluate the basic criteria of code quality, and after that check more high-level metrics. For example, if the build of the test code fails, we don't have a reason to start test at all, because okay, build fails, no reason. So according to this strategy, we start our pipeline with a code building check, after that code style check, and the linters to evaluate code quality. And for code quality, we are using Kadana. This choice is not only about dogfooding our product, but also about its extremely useful features for optimizing code and improving its quality. And after that, we check tests in the same order as the testing pyramid, starting from the lowest level, unit tests, and continue to the system level of testing. And after functional testing, you can proceed with non-functional checks, such as performance, security, or usability checks. And there are no limits, so you can add any possible checks you want to control automatically. And I can say the only thing that can stop you is the time limit. So the normal pipeline should not affect the development process. So it's impossible to wait for the pipeline during the whole day. So the normal pipeline duration is about 10, 20 minutes as maximum. And all of these stages, of course, should function as quality gates. And the code cannot be merged to the main branch without these metrics being successfully met, which means we achieve here really like automated quality control. Yeah. And yeah, so let's take a look at our CI/CD pipeline. It can be different for the backend and front-end repository, but the idea is the same actually. And we have added linters for code quality and all levels of tests. And finally, our most important test, check coverage, of course. Okay, so we go through all steps here, and yeah, we completed all necessary steps, and the testing process have been put on track, and test automation can autonomously continue to develop and maintain itself as a system. First of all, here about conclusion, I think we can say that there is a strong temptation to jump deeply into automated test implementation right now. And there is a pretty good chance that you have to rewrite them several times during the first phases of product development. Anyway, so the most significant thing is in very beginning is to analyze with your team what changes will cost you a lot of money later. And as we discuss, usually the development teams forget about the stability, infrastructures, and release process. So yeah, also the second mistake is being focused on the number of automated tests. Of course, it's a good to have high-level degree of test coverage, but sometimes the number of automated tests says nothing, literally, about the real quality of a product. So I highly recommend thinking more about our metrics, like the time required for the implementation of new automated tests, or the degree of coverage provided by them. And yeah, we have talked about investment in the infrastructure to allow us to write tests really fast and reuse a lot of existing code. So this optimization could bring us to a new level of processes where we don't need to execute manual tests, since doing so takes more time than writing automated ones. So yeah, and the last point is that often building something successfully is not about the number of like local actions. It's about the creation of an ecosystem and the creation of rules in fully prepared process. And the most important aspect here is the creation of a system of control results. For example, we can write several unit tests, but it wouldn't be a contribution to our unit test agreement. The solution that really works is to prepare the exact algorithm of how and when to write unit tests and set up an automated system for control of level unit tests. And I think only in this case, our process will work autonomously without us. Yeah. Yeah, 1 second. Yes, so we have discussed our fundamental beliefs, and now let's go deeper into practical results. So the metrics that we managed to achieve. First metric is testability. So testability has a really high level that allows us to set up the CI/CD execution of tests without any trouble. And also the second point, the release process. And the release process has been set up as a separate pipeline and supports automated UI and API compatibility checks. So it's also, I think, great result here. So as for testing CI/CD pipeline, the maximum CI/CD pipeline time is about 20 minutes, yes, as we saw, I think, yeah. And this result is a good and bad at the same time, because we are satisfied with the current result, but have a plan to optimize it at least twice. And as for test coverage, I think we achieved really good metrics, about 65% for unit tests and 70% for API tests. And as for UI, I think it's about 95%. So it's also I think great result. And yeah, it sounds really good. But the most difficult task here is support the same level further, of course. So we will be focused on it. Yeah, and I think, yeah, it has been a great journey with a lot of lessons learned. I'm extremely happy to share our experience with you. We provide more details on how to avoid the most painful problems, and also thank you for your attention. Please feel free to ask any questions you might have. Yeah, but I think we don't have a lot of time anyway. I will answer them in the chat. So yeah.
Yes, we have lots of questions coming through. So
Yeah.
if you could answer a couple of them maybe, and then answer the rest of them in the chat. So the number one got voted the highest. So what are the disadvantages of having product and test code in the same project?
Okay. Okay, I think there can be disadvantages if we are talking about microservices. So for microservices, this approach can work, but we should think more about how to manage integration level of testing, because here sometimes yeah, it can be a problem. Yes, but if we're talking about classic web application, actually I don't see any significant disadvantages here, so I can say just nothing in my brain. Yeah.
Cool, cool. The next one that voted highly was number 5. How do you manage the CI integration when there is a front-end feature that requires a new back-end feature? The front-end build is blocked until the back-end one is fully merged.
It's the last question, right? How do you manage? Okay.
Yeah, that one, yeah.
Front-end feature that requires new backend feature. Nope, actually, no, it's not fully blocked. Yeah. Okay. For example, if we imagine situation that one feature right now in the process of development on backend side and the same in front-end side, we just need to run our CI/CD pipeline in front-end side on this feature branch in backend side, because actually usually good CI/CD pipelines contains like option which branch to run on. So yeah, usually it's not a problem. I think it depends on your infrastructure and how you build your CI/CD pipeline. Yeah, so yes, I think you actually can mark this backend branch, feature branch, as dependency for your CI/CD pipeline. Yes, and everything will run on this backend feature branch and on this front-end feature branch. So it's really flexible process. So you can put any version of backend and front-end together to one CI/CD pipeline. Of course, if your CI/CD pipeline is fully prepared for it. Yes. I hope.
Good.
Yeah, actually, it's really difficult to show here in the air.
Yeah, absolutely. We need a diagram, I think.
Yeah, I can draw here.
Maybe we have time for one more question. How would you create a test pipeline if you had limited resources? Say you had 3 people, would you skip some steps,
Yeah,
prioritize
it's a
some
really good
others?
question. Yeah, I got it. Yeah, it's really good question because I think we was in the same situation as I said in the beginning of my presentation that we have only one quality assurance specialist and it was me. So yes, of course, the most important part here that I but most of our UI tests and API tests and our test was done by developers. And for me, it's the main task to prepare everything for like process, infrastructure, also control, as I said, to manage to set up these tests by developers. Yes. So I think yeah, it's really popular question. So we just have to prepare everything for developers and um, yeah, ask them to help us. So
Great stuff.
because yeah,
Go ahead. Go ahead.
yeah, we can proceed with next question. Yeah.
We're out of time now. I think we're going to break for lunch, and we give everyone a bit of time to have a break between the next talk. So I've posted all the questions to Aleksandra. Yeah, maybe reach out to her if you want your question answered in more detail. And yes, so thank you for your talk. That was really interesting. And yeah, we're going to break for lunch. Thanks, everyone.
Thank you. Bye bye.